Hello students, welcome back. In this video lecture, we are going to discuss about kinetic theory of an ideal gas, where we are going to interpret the meaning of the temperature using the kinetic theory. The topic is from chapter 13, kinetic theory. Now, in previous class alli ನಾವು using the kinetic theory expression for the pressure of an ideal gas ಅನ್ನು ಡಿರೈವ್ ಮಾಡಿದ್ದೇವೆ. ವಿಡಿಯೋ ಲಿಂಕ್ ಅನ್ನು ನಾನು ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಪ್ರೊವೈಡ್ ಮಾಡ್ತೇನೆ. In this equation, if we multiply both sides of the expression with volume of the given gas, then we will get PV is equal to 1 by 3 into N into capital V into M into V bar square. M is mass of each molecule and V bar is representing the average velocity of each molecule. Here, when we consider the product of number density small n and volume of the given mass of the gas, then it is equal to the total number of molecules present in the sample, which is represented as capital N. ಇಲ್ಲಿ substitute ಮಾಡಿದಾಗ we will get PV is equal to 1 by 3 into capital N into mv bar square. Now rearranging the equation ಅಂದ್ರೆ right hand side ಗೆ numerator ಗೆ and denominator ಗೆ 2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ equation ಅಲ್ಟರ್ ಆಗ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಬಟ್ ಇದನ್ನು rearrange ಮಾಡಿದಾಗ numerator 2 ಅನ್ನು ಇಲ್ಲಿ ಡಿನಾಮಿನೇಟರ್ ಇರುವಂತ 2 ಅನ್ನು ಇಲ್ಲಿ ತಂದಾಗ we will get this equation 2 by 3n into half mv bar square. ಈ term half mv bar square, it will be representing the average kinetic energy of each molecule. From the definition of the kinetic energy, we know that half mv bar square is representing the average kinetic energy. Internal energy of an ideal gas is purely kinetic. ನೋಡಿ, ideal gases ಅಲ್ಲಿ we are assumed that there is no force of attraction between the molecules amongst themselves. Hence, internal energy ಇಲ್ಲಿ ಅದನ್ನ ನಾವು ಕ್ಯಾಪಿಟಲ್ ಇ ಇಂದ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಿದ್ದೇವೆ, which is sum of all the energies, that is potential ಮತ್ತೆ kinetic. Potential energy 0 ಇರ್ತಾ ಇರೋದ್ರಿಂದ internal energy of ideal gas should be purely kinetic energy. Internal energy should be equal to energy possessed by each molecule half mv bar square into the number of molecules present, capital N. ಇಲ್ಲಿ ನೋಡಿ n into half mv square is equal to E. ಇದನ್ನ ನಾವು ಯೂಸ್ ಮಾಡಿಕೊಂಡು we can write PV is equal to 2 by 3 into E. Now rearranging the equation for the internal energy. E is equal to 3 by 2 into PV ಅಂತ ಬರೀಬಹುದು. ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ, 2 by 3 ಅನ್ನ other side of the equal sign ತಗೊಂಡಾಗ it will become E is equal to 3 by 2 into PV. ನಾವು previous section ಅಲ್ಲಿ ನೋಡಿದ್ದೇವೆ the expression for the PV is equal to NKBT ಅಂತ, where KB is representing the Boltzmann's constant, T is representing the absolute temperature. ಇದನ್ನ expression for the internal energy substitute ಮಾಡಿದಾಗ we will get the internal energy should be is equal to 3 by 2 into NKBT. We already know that the average kinetic energy represented as total energy divided by number of molecules present. E by N should be is equal to half mv bar square. And also, if we rearrange this equation to get the average kinetic energy, we will get average kinetic energy is equal to 3 by 2 kBT. ನೋಡಿ, ಈ equation definition ಇಂದ obtain ಮಾಡ್ತಿದ್ದೇವೆ. Second equation for the average kinetic energy ಅನ್ನ the above equation ಇದರಿಂದ obtain ಮಾಡ್ತಿದ್ದೇವೆ. ಎರಡನ್ನೂ ಕಂಪೇರ್ ಮಾಡಿದಾಗ we can see that the average kinetic energy of a molecule is proportional to the absolute temperature of the gas. Average kinetic energy ಏನಾಗಿದೆ, it is independent of the pressure, volume or even nature of the ideal gas. ಅಂದ್ರೆ ಮೊನೋಅಟಮಿಕ್, ಡೈಅಟಮಿಕ್ ಅಂಡ್ ಪಾಲಿಅಟಮಿಕ್ ಗ್ಯಾಸಸ್ಸಿಗೂ ಸೇಮ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಮೇಂಟೈನ್ ಮಾಡಿದಾಗ those will possess same average kinetic energy. From the equation, E is equal to 3 by 2 PV, which is equal to 3 by 2 NKBT. ಈ equation ಅನ್ನ rearrange ಮಾಡಿದಾಗ ನೋಡಿ, in this equation, if we substitute the value of E is equal to capital N into half mv bar square, then we will get value of PV is equal to 2 by 3 into E, which is in turn is equal to 2 by 3 into N into half mv bar square. 2 and 2 cancel ಆಗ್ತಾ ಇದೆ. ರಿಮೈನಿಂಗ್ ಟರ್ಮ್ ಏನಾಗಬೇಕು, P must be is equal to 1 by 3 into N divided by V into mv bar square. We already know that total number of molecules divided by volume will be representing small n, number density. Hence, expression for the pressure P is equal to 1 by 3 nm v bar square ಇದೆ ಅಂತ. For a mixture of non-reactive ideal gases, the total pressure gets contribution from each gas in the mixture. The equation for the pressure will be equal to P into 1 by 3 into N1 M1 V1 bar square. Pressure exerted by the first gas and represent ಮಾಡ್ತಿದ್ರೆ 1 by 3 into N2 M2 V2 bar square represents the pressure exerted by the second gas alone. Therefore, net pressure will be is equal to sum of the pressure exerted by all the gases. In equilibrium, they are at the same temperature. ಆವಾಗ average kinetic energy of all the molecules, that mixture of gases, same ಇರಬೇಕು. ಯಾಕಂದ್ರೆ average kinetic energy depend ಆಗ್ತಾ ಇರೋದು only on the absolute temperature at which it is maintained. Hence, we have average kinetic energy of individual molecules of different gases is given as half m1 v1 bar square should be is equal to that of the other gas half m2 v2 bar square, which should be is equal to 3 by 2 kBT. Same temperature ಅಲ್ಲಿ maintain ಆಗಿರೋದ್ರಿಂದ same average kinetic energy for different gases. Therefore, we can write P is equal to N1 plus N2 plus so on into kBT. Using the expression, now P is equal to 1 by 3 into N1 plus N2 ಕಾಮನ್ ಆಗಿರುವಂತ ನೋಡಿ ಎರಡರಲ್ಲೂ ನಾವು ಹಾಫ್ ಅನ್ನು ಎಕ್ಸ್ಕ್ಲೂಡ್ ಮಾಡಿದ್ದೇವೆ. Therefore, M1 V1 bar square should be is equal to M2 V2 bar square, that should be is equal to 3 kBT. ಅದನ್ನ ನಾವು ಹೊರಗಡೆ ತಗೊಂಡಾಗ we will get this 3 and 3 cancel ಆಗ್ತಾ ಇದೆ. We will obtain given equation. This is nothing but Dalton's law of partial pressure. ಈಗ ನಾವು RMS value of the speed ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ. Container as a whole consider ಮಾಡಿದಾಗ it will be at rest. Only molecules within the container are in motion. ಅದರಿಂದಾಗಿ ಏನಾಯ್ತು, ನಾವು average velocity of all the molecules ಅನ್ನ ಕಂಬೈನ್ ಮಾಡಿದಾಗ 0 ಬರ್ತಾರೆ. That's why first we are going to square the velocity of individual molecule, then we are going to add velocities of all the molecules, then we are going to take the mean value, then square root it. We know the expression half m v bar square is equal to 3 by 2 kBT ಅಂತ. 2 and 2 get cancelled. We have v bar square should be is equal to 3 kBT divided by n ಬರ್ತಾ ಇದೆ. ಎರಡೂ ಸೈಡ್ ಗೆ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಮಾಡಿದಾಗ we know that square root of v bar square is vrms. It should be is equal to square root of 3 kBT divided by m. At same temperature, lighter molecules will have greater RMS speed. ಯಾಕೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಸೇಮ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಮೇಂಟೈನ್ ಮಾಡಿದಾಗ different molecules will be having the same average kinetic energy. vrms should be proportional to square root of 1 by m. Therefore, ಯಾವ ಮೊಲಿಕ್ಯೂಲಿನ ಮಾಸ್ ಗ್ರೇಟರ್ ಇದೆಯೋ ಅದರ RMS ಸ್ಪೀಡ್ ಏನಾಗಬೇಕು, ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗ್ಬೇಕು. ಯಾವ ಮೊಲಿಕ್ಯೂಲ್ ಲೈಟರ್ ಇದೆಯೋ it will be having the greater value of RMS speed. Because of the same reason, when gases diffuse, the rate of diffusion is inversely proportional to the square root of the masses. The molecule with a higher RMS speed, it will diffuse very quickly. RMS speed ಏನಾಗಿದೆ, it is inversely proportional to the square root of 1 by m. Therefore, the rate of diffusion ಏನಾಗಬೇಕು, it should be inversely proportional to the square root of masses. Again, if we consider the mixture of gases, ratio of their RMS speeds depends inversely on the square root of their masses. Illi composition of the mixture by mass is irrelevant. Andre the mixture of gases, andre gas 1 ಏನಾಗಿರಬಹುದು, it may be having the twice the mass as that of the gas 2, but still the ratio of RMS speeds should be inversely proportional to the square root of their masses. ಇಂಡಿವಿಜುವಲ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ನ ಮಾಸ್ ನ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಗೆ ಡಿಪೆಂಡ್ ಆಗಿರಬೇಕೆ ಹೊರತು ದ ಟೋಟಲ್ ಮಾಸ್ ಆಫ್ ದ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ದ ಗ್ಯಾಸ್ ಇಸ್ ನಾಟ್ ಅಫೆಕ್ಟಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ VRMS. Students, I hope you have understood the concept. Thank you for watching the video. I wish you happy learning.